This is for Year 12 methods. It comes out of 6.5, question number 5. Joseph is competing in a surf life-saving competition race. He is standing on a long, narrow point of land which juts 5 kilometres out to sea directly opposite the Surf Life-Saving Club. There's the Surf Life-Saving Club on land. That's where he starts his race, 5 kilometres out to sea. So that's 5 kilometres along there. The finish line is 8 kilometres along the shore. So the finish line along here is 8 kilometres from the Surf Life-Saving Club. If Joseph can swim 7 kilometres per hour and he can run 16 kilometres per hour, find the position along the shore that he should aim to minimise the time. So we're minimising the time. So I need an expression for time, an equation for time, and I need to minimise that time. And the concept, or the way this question is set up, is Joseph starts here and he has to swim to some point and then run the rest of the race. So he's going to have a swim component and he's going to have a running component. So we want the time that it takes him to swim plus the time that it takes him to run. So we need some connection between speed, distance and time. I know that speed equals distance over time, therefore time's going to be distance over speed. So t is going to equal the distance of the swim divided by the speed of the swim plus the distance of the run divided by the speed of the run. I know that the speed of the swim is 7 kilometres per hour, and I know the speed of the run is 16 kilometres per hour. I need to find the distance. Okay, for the running component, if I call this bit x, the distance away from the Surf Life-Saving Club that Joseph comes out of the water, then he will run 8 minus x. So the distance of his run is 8 minus x. If I'm looking at this right angle triangle, that's 5, that's x. This is how far he swims. So that's going to be the square root of x squared plus 5 squared using Pythagoras' theorem. So it's the square root of x squared plus 25. I need to minimise the time he takes to swim. So I need an expression for dt dx. I need that to set that equal to 0 and solve for x. So on my calculator I'm going to bring up so I have time, which is the square root of 25 plus x squared over 7 plus 8 minus x over 16. I wish to take the derivative with respect to x. I wish to set it equal to 0 and I wish to solve for x. So the derivative of the time with respect to x equals 0, interactive advanced solve for x, okay, and that's where he should get out of the water. 2.43 kilometres from the Surf Life-Saving Club. So that gives me an x value of x equals 2.43. Therefore, Joseph, to minimise his time, should get out of the the water, 2.43 kilometers from the Surf Life Saving Club. What would that look like if I graphed it? I know that the maximum he can swim is 8, so I go from 0 to 8. Okay, if I take the time, I drag and drop the time, zoom, auto. There is all of the times it will take Joseph to swim. An analysis, G-solve minimum. The minimum occurs when he gets out of the water at 2.43.